Hey, what's up, guys? Welcome to the channel once again. If you haven't subscribed to the channel, please do subscribe to the channel and like the videos to support the channel. Today, we will be going over some basic skills of Wireshark. Let's get into it. First off, let's start up our Wireshark at the background. So we do sudo Wireshark and then we put it at the background. Okay, so we started our Wireshark. It's going to be starting up. So you could see that I have a lot of interface. But the only interface that is of interest here is the if0, right? So I'm going to start up my capture, and then I'm going to go over to my Metasploitable 2 machine, and I'm going to start up my utility, another vulnerable web application. So here we go, and then I'm going to try to log in. So we click on login, and then I'm going to log in as an admin so we can, generate some traffic on the Wireshark. There you go. We started it. We log in as an admin. Okay, don't save. We log in as an admin. All right, and I'm going to start some traffic on one of the secure sites. So let's say, how about we do Yahoo? Okay, or maybe Google.com. Here we go. We start some traffic on google.com. So now we're going to toggle over to our Kali to our Wireshark, and then we can see we have a lot of captured traffic. All right, so we're going to stop this capture, and then we can go over the basics of Wireshark. All right, so first off, we have this. Let's go over the main menu that we're going to be talking about, or the main toolbar here. We're going to be talking about the main toolbar. So here you see this icon. Whenever you want to start a new capture, a new packet capture, this is where you're going to click, and this is where you're going to start the capture, right? And then this one basically restart your current capture. If you want to restart whatever you capture here, you can click on that to restart your current capture. This talk about what the capture interfaces, right? So actually this one is all the interface that we have. We're going to be talking much about the interfaces and what we can do with the promiscuous mode and what have you, but let's move on. So here we can actually open up an old capture packet, or traffic that we've captured and then saved. So you can capture the traffic, your packets and everything, and save it for later analysis. So if that happens, you can click on that icon here, and then you can navigate to wherever you save it, and then you can upload it back onto the Wireshark for your analysis. All right, moving on. We have this. This is going to be what this icon is going to save the current capture. So whatever capture we have here, we can actually click on this, and then we save it, to a location of our choice. If we don't want to do the analysis right away, we can save it and then come back to it and then, do the analysis. All right, moving on. So this one here is actually going to exit or close out of this existing capture that we have here. So once you click on this, it's actually going to, close all this capture and then maybe start the capture afresh. And this is going to actually refresh this capture. So you see it actually refreshed the capture for us. And then and this one here actually is going to display whatever packet you're looking for. So let's say, for instance, if I click on this magnifying glass here, and I was putting a string like, say, password. I'm looking for a string that starts with password, right? So here I'm just going to change the display. I'm going to use a string. That's why we have in the arrow, right? So I change the display to string, and then I'm going to maintain it for narrow and wide. And I want to search in the packet detail to see where I can find a password, right? And then I click on find. So now this will tell me exactly where I can locate what packet contain password. So when I look down in this packet bytes, I can actually see, it contains the word password. If you pay attention, you can actually see it contains password in here. So we're going to be looking at that later. So this is what this is doing. If you know the exact string you're looking for, you can actually click on the magnifying glass, and then you can put in the string you're looking for, change it to the packet details, and then you can find it and actually say it. All right, so moving on. Let's cancel out of this. So moving on here, this arrow actually is like your down and arrow key, key on your keyboard. So if I have this, say I have this packet selected here, right? And I click on this arrow, it's gonna move to the packet list above it, and then I can keep going up like that. But if I want to move down, I can go here. So this is like more or less like an up and down arrow key on your keyboard, right? All right, so this one actually go to a specific packet. So if I click on this and I move down to this place here, I can actually say, hey, let me show me packet number 114, right? So I'm just going to click on go to packet, and then you see it takes us directly to the packet number 114, right? All right, moving on. So this one here is actually going to display, it goes to the first packet. So when I click on this, it goes to number one packet for me. If I click on this, it actually goes to the last packet of the capture that I have. All right, that's pretty simple, right? And then also this one here is actually going to go what? It automatically, as you capture the traffic, this is by default. It always displays the last packet. So this is actually set by default. So even if you don't do anything with this, it actually will show you the last packet. It will highlight the last packet for you. And this one here displays what the packet colorization rules. If you want to see how this works, we can go to view, and then we go down to where it says coloring rules. You click on that. So you actually see that all the protocols that we have specific color attached to them. Right, so we have the UDP, which is blue. We have the TCP reset, we have which is red, and then we have the checksum error, which is black, and the HTTP green, SMB, yellow, and what have you. So the rules, you can actually change the rules if you want. You can change the rules to, but if you want to maintain the default, that's perfect. And here you can actually magnify, the view of your capture, and then this one you can zoom out of it or zoom in. You can reduce the magnifying, you can actually increase the magnifying with this, and you can reduce the magnifying here, or you can actually click on this one to return to the default magnifying. And this one here is for you to just resize the length of the columns of the capture, so we can move this back and forth as we choose, just so we can get some more working space. All right, so so here you can see that the time is not displayed properly. So we can go to view, and then we go to time display format, and then we might want to start with the date and time of the day. We click on that, so we kind of arrange that, the date, and then we have the date and then the time of the day. We can also add some more. We go to time display format, and then we're going to go, let's add some seconds. So here we actually added some seconds. All right, so now we've arranged the time display format to make sense. So now let's look at the second item on the Wireshark that we want to take a look at. So we looked at so again the Wireshark is actually displayed, the standard or the default display. We have the packet list. So this pane here or this pane here, you're saying this area here is called what? The packet list. This is where it lists the individual packet that is being captured. And then the second area we're going to look at is what? The packet details. So this one actually displays the packet details. It displays whatever detail you want to see. So when you click on each of this packet, it actually displayed its detail down here, right? So we're going to be looking at that as well. And then the third one here is what? The packet byte. It actually displays the packet in its raw format. So the packet byte display the captured information in a raw format like hexadecimals and binary. So for instance, this one is displayed in what? Hexadecimal. We can right click here, and then we can change it to save as bit, and then it's going to display the information as bit. Let's move it back to the hexadecimal. Before we move on, show bytes in hexadecimal. So this is the function of this portion here. It displays the information captured in raw detail. So now we're going to look at the second pane of the main Wireshark window, which is the what? The packet details, right? So this place here actually displays the packet details, right? So when you take a look, when you see we have 4 layers within this packet detail, right? All right, so now let's go over each of these layer. So the first one is going to be the frame. So the frame here contains information about the size of the packet, the interface it was sent on, and so on. So it actually shows us the size of the packet that is being sent, right? All right. So the second one here is going to be the Ethernet, right? So what does the Ethernet does, or what does it contain? The Ethernet layer contains the source and the destination MAC address. The SRC, which is the source. So we have the source MAC address and the DST, which is the destination. This is the destination MAC address. So here, and also we can see it here, we have the destination and then the source. So the destination and the source MAC address is actually displayed in the second layer, which is the Ethernet, right? All right, moving on. Now let's look at the third layer, which is the Internet protocol. We open up the Internet protocol. What does the Internet protocol contain? This shows information about the source and the destination IP address. So you go down, you can actually see the source, and then you can see the destination IP address. So the third layer here in the Internet protocol shows us both the source and the destination IP address of the communicating computers. And then the fourth layer here is what? The transmission protocol, right? So the transmission control protocol, we have information about the protocols and the port being used. And that's exactly what we've seen here. We've seen the source port as well, port 80, and then the destination port as well, port 42872. These are what information we found in the fourth layer. All right, so now the most important layer here is going to be the fifth layer. So let's look at the fifth layer, how the fifth layer looks like. So we click on this one here that contains the post uh, request. We can actually see the fifth layer being displayed here, which is what? The hypertext transfer protocol. So the hypertext transfer protocol, this is the most important layer. This is the data sent over the HTTP protocol. This is the most important layer, which is the hypertext transfer protocol. You actually see a lot of information here when you actually expand it. All right, we're going to be looking at that. Now let's go over how we use filters. All right, so for instance, if I want to, filter, so again, we're going to go over to what the filter bar, right? That's where we're going to actually specify what we are going to be filtering our traffic based upon, right? So what does the filter bar, what does it do? The filter bar actually it filters the packet based on whatever search term you pass it or you give it, right? So let's do HTTP. So right off the back, you can see that when I type in something that is not a valid protocol, like HTTP without a P, you see that I have a light pink background. This is showing me that I have an error, or this is throwing an error because there is no such protocol. That is what HTTP, right? But if I pass in the right protocol, I get a green background. That is telling you that whatever filter you're using is actually a valid and is a correct protocol and a filter, and it's going to give you a valid result. But if you see a light pink, you know that whatever filter you're using is not valid, and then you can change it. So I'm going to search. I'm going to search the traffic based off what HTTP. So right now you see I have most of the HTTP. Why am I seeing this HTTP traffic? Remember, because we searched, we actually started this Matilde web application, and Matilde web application is actually a vulnerable web application. It runs off what? HTTP. That's why we're seeing the HTTP in our traffic, right? So now let's search with what HTTPS. And then right off the back, you see that it's throwing an error because it's giving us a pink background, which means it's an error. So why is it an error? Because HTTPS, you cannot search using this filter. If you want to search on the HTTPS, you search with what? TLS. And why TLS? TLS is actually what? The extended version of what? HTTPS, using a stronger encryption. So whenever you're searching for HTTPS with Wireshark, you can search with what? TLS. All right, so now you see that we have TLS. Why are we seeing this? Because we actually run what? We went to google.com, and google.com is actually running on what? HTTPS protocol. That's why we're seeing it in our Wireshark, right? So google.com is running on what? TLS version 1.2, right? And that's what? HTTPS. But you cannot search it with HTTPS. We have to search it with what? TLS, which is an extended version of the HTTPS. All right, moving on. So now we're going to search, we're going to filter based off what IP address. So we have IP.addr and then we have equal equal. So I'm going to use one of the IP address of the boxes that I'm using, that 2.29. So see, so this search IP that address equal equal 10.02.29 is actually going to show us all the traffic flowing through this IP address, everything back and forth, destination or source IP, source address, everything that is flowing through this traffic is going to be displayed. But if I want to be specific and I search for just the source IP address, so it's going to be IP SRC, and then I search. So right, you can see that the source address is actually going to be what all the metasploitable IP address, the .29, all the communication, all the traffic coming from this IP address is going to be displayed here as a source IP, right, to this destination IP. So what if I change this source to DST, which is what the destination DST? So you're going to see that my destination IP is actually now changed to what, 29. So all of this, you can actually use this filter. You can filter based on the source IP or the destination IP. All right, moving on. All right, so now let's search based off what ports. So we have port TCP dot port, and then we can specify whatever port we want to use. Say we want to use equal equal port 80, and this is going to show me the port 80, right? So whatever communication or whatever traffic is pushing through, is coming through port 80 is going to be displayed. And also I can do this. I can do TCP the port in, and I can pass in multiple port numbers. I use the curly braces, and then I'll put in, say, port 80 and then 443. And this is going to display all the traffic from or all the traffic passing through port 80 and for port 443. All right, so you see, that's how you can actually pass this search. And again, we can also do combination of what protocols. So if I have HTTP and I can use or TCP, right? This is also valid search. You can search it. So I'm looking for traffic coming in from HTTP or TCP. Or I can also add another port, which is, say, UDP. You can actually use multiple port and do your search, or multiple protocols, sorry. So now you can see that I have HTTP or TCP or UDP. So they're actually going to show me if I have all of these protocols, everything will be displayed here for me. All right, moving on. Say if I search SSH, you notice that I'm not going to see anything because I didn't have anything running SSH on my machine. So if I don't have any traffic coming in through or from SSH, I'm not going to see any traffic displayed. So let's say UDP, I have the UDP port coming in because I have the DNS, on port 53. All right, moving on. Now let's look at another filter, which is what TCP contains. We know that we visited what Google here, so we know we have some string that has the name Google in here. So we're going to go here and say TCP contains Google, and then we search. So we have one packet coming in from that, and then you go straight to your packet byte. In the packet byte pane, you could actually see that we have some traffic that has what Google. Okay, so now if I go down to the Ethernet, I can actually see the MAC address, the source MAC address, and the destination MAC address of whoever visited this site, right? And also I can go to the Internet Protocol to see the source IP and the destination IP of whoever visited this google.com. So you see I have what the destination address and the source IP address, right? So the source IP address, this is our communication back to my box, and then the person who actually requested that communication originated it from this box, which is my Kali box, right? Okay, so you could do analysis of based on your string, and then you could go down further and see who actually visited that site. Let's do TCP contain password. And then you can see we have multiple that contains passwords. So let's say, knowing that this is a post request, we know a post request contains what, a post form that will require, a user to input a username and a password. So right off the back, this will be my traffic or my packet of interest. I click on that, and then I go down to the hypertext transfer protocol. This is where I will base my analysis because I know there's a post request here. So definitely password will be here. All right. So I go down and do my analysis and see if I can pick up something. All right. So we're going to go down and back. You can see the username that I use for my material today, which is this unsecure site here, is admin. And then the password that I use is what? Admin pass. So when you do TCP contains whatever string you're looking for, you can actually do an analysis based off the packet that was displayed or that is displayed for you. And you do analysis and you go actually look for whatever string you're looking for in the packet detail pane. And also, there's one more thing that I want to point down here. So you see this arrow here. This arrow is actually this little tiny arrow down here. This is a request arrow. So you see, this is a post request. And then you go down. This arrow will be what, a respond arrow, because it is actually responding to whatever we requested. Okay. All right. Moving on. Let's say your analysis requires you to capture particular traffic coming in, not all the traffic coming into your interface. You just want a specific IP address on a specific port or on a specific IP address. Let's see how we do that. We're going to stop this, continue without saving, and then we're going to stop the capture completely, right? And then you're going to go here where it says the capture option, or you can actually go here and then you can select the option. So whichever one you want to use, that's fine. You can go here and then you see where it says capture filter for selected interface. All right, so this is where you're going to specify the exact capture you want to use, right? So let's say I want to only capture the traffic coming in from HTTPS, and I'll do HTTPS. And I'm seeing that this is throwing an error, like the light pink error. So why am I not being able to select the HTTP? Because this is not how you specify this capture here. You have to specify the port on which HTTP runs on. And we know that HTTP runs on what? Port 80. So I'm going to specify TCP port 80. And this, I'm telling Wireshark to capture any traffic coming in through port 80. And I'm going to start capturing. All right. So I'm going to navigate down to here and I'm going to go to, say, yahoo.com. All right. So now let's go back to our capture. All right. So you see, we have a lot of capture, but when you take a look, we're not seeing any 443, even though we went to yahoo.com, but there's no 443 listed. So we could do that, verifying TCP, the port equal 443. And you see, we have no traffic coming in from port 443. All right. Okay, cool. Now let's stop this. And then we're going to go back here and then we're going to clear this filter. Now we want to capture in traffic coming in from port. Well, let's use the same port, right? Let's use TCP port 80 and then we start this. Okay, so now we have TCP port 80 coming in. Let's clear this filter. We have port 80 coming. So when I go back to this place and then I go to my, let's log out here. And I'm going to log in again and see if we're going to capture any traffic coming in from here. We have admin pass. All right, so now we logged in. Let's go back to our, see, we have a lot of this traffic capture. Let's stop. And then we can do a search and see if we have TCP, the port 443, TCP, the port equal 443. See, we're not seeing anything because it is not capturing that. But let's say we want to see 80. See, we have a lot of 80. Why are we seeing 80? Because 80 is what port 4, 80 is running on what, HTTP. and then HTTP is what we visited with this unsecured website. So you see the difference. You can actually specify the type of capture you want to capture right off the back. All right, so now let's stop this and go back into let's go into setting up and then set up as what port. Let's set it up as port TCP port 443 and start the capture. I'm going to remove the filter. Let's go back here and then we can start yahoo.com. Okay, let's go back to our filter. You see we have a lot of capture. We're going to stop this and see if we can find any port 80. TCP.port equal 80. See nothing here, but let's see 443 for our Yahoo site. Yeah, 443. We enter, we see a lot of the 443 right there because you specify the type of capture you want from the beginning. So it's not going to capture any of the traffic you don't want. So you can specify what port or what traffic you want from the beginning. So we're going to stop this and then we clear up this filter. Then we're going to say now let's look at a specific IP. Maybe you're doing an investigation as a SOC analyst or something, and then you want to see a specific traffic coming in from a specific IP or a particular IP. You can, if you do IP dot addr, you're going to get an error because that's not how you specify it here. So I'm repeating all this so you know. But how you're going to specify is host, and then you specify the IP. So let's say I want to specify anything coming out and in and out of my Kali machine that 15, right? So I'm going to start the capture. Without saving, I'm going to go here, uh, sign out real quick, sign up, and then re-sign in, admin. Then we have admin pass. All right, we just signed in, we're gonna save. All right, let's refresh this real quick so we can have some capture. All right, so we captured some traffic. I'm gonna create this filter here. All right, so you see, we have what? This host alone. Now let's talk about something else. All right, so I'm gonna stop this and start another capture. And clear my filter. So I'm port range. So I could do port range right here, and then I'll specify the port that I'm looking for. So let's say port 10 to 443, right? And then I'll start my capture. All right. So if I go to here and I'm gonna restart my capture and I'm gonna log out and then log back in with my password admin. Okay, on save. So we go back to our capture. So you see we have capturing happening from this port range. If the traffic does not fall within this range that we specify as our capture packet, it's not going to be captured. All right. So now let's talk about the promiscuous mode. I'm going to stop this and then I'm going to go to the capture promiscuous mode. Any traffic, you see where it says enable promiscuous mode on all interface. This means that all the capture, it captures all traffic flowing through the specified interface. If I don't want the traffic to be, to be sniffing traffic on all my interfaces, I can disable this, and then I'll specify the exact interface I want to be, capturing traffic on, because by default, devices are set to capture traffic flowing into them alone. But if you set a promiscuous mode, it means that they can actually sniff traffic that are not even destined to the devices. Even if they're destined to another devices, as long as they are on the same interface, they are able to capture that. So that's what the promiscuous mode is doing. Promiscuous mode actually sniff all traffic, even if it is not destined to the device. All right, so you can actually select, or if you want to, just specify a particular interface and a particular device, you can deselect and then select whatever interface you want. But usually by default it is enabled to be on a promiscuous mode on all interfaces. I'm going to do it for the intro to the basic skills in Wireshark, and I hope you've learned something and you've enjoyed the video. If you did enjoy the video, please do like, give us a thumbs up, and subscribe for more videos. If you haven't subscribed already, it's going to help the channel. Thank you again. I'll see you next time.